which is a totally new approach to combination lock. It doesn't have dials or something, but a completely different design. And the other unusual lock we want to talk about is the magnetic code system. So this is a lock using magnets, obviously, and it's a very secure one, so it's of special interest to many lockpickers around the world. And then they have some conclusions what our research would mean for people interested in security. Okay, it's about unusual locks and how to open them. And we have to admit there's not so much real picking in the classical way with a lockpick inside the lock involved, but more opening them by decoding and by replicating keys and changing keys. So what we want to show you today is the result of some research we did in the last years, or the last year or something, when we analyzed the locks I mentioned and played around with some other stuff. First, I want to give a short disclaimer so we're not sued afterwards. We just report from our personal experience, so don't believe everything we tell you. It's just what we concluded from the things we saw when opening these locks. So it might be that different locks of the same brand behave differently. We don't claim that all locks operate in these principles. We also want to mention that the locks we show here, especially the Janus and the magnetic code system, are not weak just because we defeated a few of the security features. The opposite is the case. These are very good locks, and that made them interesting to us. So we did it not because it was easy, but because it was hard. And did the other thing. Okay, the first thing I wanted to talk about is key control. What is that? Key control basically is the ownership of your keys as a manufacturer. What manufacturers try to do is to prevent people from duplicating a key without authorization. You know that if you have a high security lock, you get a key code card with it, and you have to go to an authorized dealer to get a copy of your key. And for this to work, the blanks must be somehow restricted so not everybody can get them and make a copy, otherwise you wouldn't need the key card. It's done by basically two concepts. One is making it technically difficult to copy the key. That's the thing interesting for us. And the other is patents. So you add some feature so you can sue anybody who makes copies of your key and violates your patents. That's not so interesting. They mainly do it because people like to have that. So the effect of this is that the sale of the key blanks is usually restricted to the authorized dealers, which is of course something we don't like as a locksports community because we want to have blanks to play around with them. So that's why we try to defeat it. Why is it important for the key manufacturers to have this key control? It's of course for the customers. If you have a large building and you have keys, it often happens you give someone a key, you throw him out of your company, he has to give the key back, and you want to be sure he doesn't have a copy. So that's why you give him just the key and not the key card. So if key control is broken, he could have a copy, and you never know if you get your key back, if he has a copy or not. It's also to prevent privilege escalation in master key systems. A master key system is something where you have individual keys for individual doors, and you have one key opening them all. Of course, it was desired that nobody is able to make the master key from knowledge of a few change keys, which is the individual keys. So it shouldn't be possible to create your own master key if you get some information about it. So if you have access to blanks, you can more easily play around with it, because usually it's not possible to make a master key from a normal key, except for the system we will show later. And the last thing is it's restriction of the blank also prevents someone from making a key if he knows the depth of the cuts, which, for example, there was an attack, I think, last year, where people took a photograph of a key and then took a blank and cut the key to this photograph. If it's not possible to replicate a key yourself, that's more difficult than if you just can file it into your blank. So does it work? No. We will show you why it didn't work for at least the systems we analyzed. Okay, one easy thing is key casting, and Iggy will talk about it a bit.
Yeah, this one is loud. The reason why key control doesn't work for 90% of the locks is that you can easily cast the keys with soft enough metal. There are nice kits available for this. You can buy them here at the Lockpicking Village. But yeah, why shouldn't we do it on ourselves? Why should we buy something when we could invent ourselves and do with a lot of time a less working version of it? So we came up with the setup. Ray, next slide, please. Yeah. This is the cast itself. It's actually a piece of hardwood floor from the renovation of the kitchen of my parents. This is famous modeling clay stuff which hardens with heat. These two are interesting. Those are metal alloys. This is wood metal. It's an alloy of lead, bismuth, cadmium and tin. And this is roses metal. It's an alloy. It's basically the same alloy, just that cadmium is replaced by indium. And wood metal has a melting point of 70 degrees Celsius, and roses metal has a melting point of 95 degrees Celsius. I would recommend using roses metal because cadmium is even more toxic than lead. And I would recommend using a well-ventilated area, wearing protection, blah, 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 blah. And don't file it too much because the filings hang around in the air and get into your floor and you get a slow cadmium lead poisoning, which you really don't want. But it works, and yeah, next slide. Yeah. Some stuff is not on the picture. You need a separating agent so that the two parts of the plaster don't stick together when closing it. Baby powder is working really, really good. Yeah, and you need the spoon for heating the metal and a candle to heaten it. Don't heat it too much because otherwise you will get the toxic fumes. But well above the melting point, otherwise it will harden too fast and you'll have lots of problems with air bubbles in your final key. Yeah, the process is straightforward. You put plaster in the mold, you put the separating agent, the baby powder on, you press the key in, you close the form with a clamp, you take the key out, you close it again, you pour the molten metal in, and yeah, you have something like this. And all these keys are working. We made a few more, but I think those are interesting ones. We have basic pin tumblers, they're working very well. We have dimple keys, they are working good. We have from the Abus X Plus, I think this is also working. I don't know what this one is, but this is an Abloy Classic and this is an Abloy ProTech, which have really small details and are really precise locks, and they work very good. There are problems with the key casting. The keys are quite brittle. They will break if you put them in your pocket. They will break if you use too much force when turning them in the lock. So they are not for regular use, besides they're toxic. The keys don't work when the casted keys don't work when the lock has moving parts in the key, like the Dome X. You could maybe as a thought insert like the small ball from the Dome X and also emulate that function, but it doesn't work straight away. The next problem is that it's hard to cast keys which have cuts or any elements on the side, because there the form separates and those details are usually lost because the precision of the form on the side isn't that good than on the flat sides. And an example for that is the BKS Janus, which brings us to the next topic, the BKS Janus lock. Our interest in this lock was sparked because we had it for a short time as the lock at the Munich Hackerspace, and by coincidence, shortly after that, we had the opportunity to investigate a quite large locking system based on the Janus, which over 50 locks and a complex key hierarchy. It's an interesting lock. It's basically an extension of the basic pin tumbler. It has up to 20 pins in comparison to the 5 or 6 pins from a normal pin tumbler, but it only has 3 depths compared to 8 depths on a normal pin tumbler. It results in a huge theoretic key space. Over 3 billion keys, 3 billion locks are possible. The pins are arranged in 4 plus 1 odd job rows around the cylinder. Yeah, and the key is working on both sides. It is basically 2 rods together, and so you can turn the key upward and downward, and it works in both ways. Only the upside is checked. On the bottom side on the lock, only the profile of the key is checked. So we liked this lock, and we took it apart and glued it on a piece of wood. And basically, this is the inner cylinder where the pins go in. This is the outer cylinder in which the inner cylinder rotates if all pins are on the shear line. This is a key, this is a key. Yeah, up to 20 pins, as I already said. 3 depths, there is the 0 depth pin, which only checks if there is no dimple on the key on the spot in the system we examined. There was exactly 1 of these 0 depth pins for every lock, which made us some problems because we made a cut there and suddenly our keys didn't work at all. And the depth 1 and 2 pins, which check for different depth dimples on the key. So this is the upside of the key and this is the lower side of the key, but only one of the sides is checked when inserting the key into the lock. Yeah, how does master keying work with the BKS Janus? You don't have enough place to make multi-part pins, so they use an interesting concept of positional master keying. So only the different pins and different dimples are on the locks, and if those match, you have a working key for a lock, and you can implement a very nice, very complex key hierarchy with this. But the bigger your system is, the less pins you have in each lock. Okay, this was maybe a bit complex. What I'm talking about is, let's say you have this lock, which checks all the green pins, and you have key 1, which has a depth 1 dimple here, and you have key 2 with a depth 2 dimple here, and obviously the keys work in, both keys work in the lock. An interesting result from this positional master keying is you have a nice intrusion vector for privilege escalation on the key, because if you have 2 keys, you get information which you can use to make keys which open more doors than any of the 2 previous keys you had. Yep. So in this example, we have this first key which opens lock A, and we have the second key which opens lock B. And if we just make a sum of the 2 keys, which has the dimples of key 1 and the dimples of key 2, we can open lock C, which has this code, which neither key 1 nor key 2 could open before. And on the system we examined, this was really interesting. Any 3 keys from the system were enough to generate a master key which could open all locks in the system.
Yeah, and something we should mention, I think, also is if you don't find all the keys you need for the master key, for example, it's like bits, you're missing a few bits, you can guess them. So you know everything except for that one position. Then you just create 3 possible master keys with all 3 depths on that position, and you have the master key again. So even if you miss a few keys, you can escalate the privileges just by guessing. The only thing you need to do is to be able to create keys.
Yeah, and because of the double-sided key, you can even put 2 keys on 1 key because, yeah, you have the upside for, let's say, depth 1 and the downside for depth 2, and you just try which one works. Yeah, how did we do it? How did we raise the writes on our keys? Our first approach was to drill the holes into the key, which worked really, really good. But as we later found out, it was overkill. There was a much easier approach. Yeah, you can just file the keys. You make a mark at the position where you want to put your new dimple. You insert the right pin for the depth of the dimple you want to have. It's either a pin 1, a 0, 1, or 2 into the inner cylinder. And yeah, then you pull out your key blank. And yeah, this doesn't look like a normal key blank. Actually, that comes in the later part. We made completely our own keys. But for the moment, let's say this is a normal key. You put this pin here. And then you take out the key and you file at the position you marked before and insert it again, and you look if the pin matches smoothly with the surface of the cylinder. And yeah, you repeat this process until it does. And for added precision, you can put the outer cylinder over the inner cylinder and check if they smoothly rotate within each other. And yeah, by this approach, we could put dimples on any position in any required depth on the keys. As I said, we wanted to make completely keys from scratch because the BKS Janus blanks are quite hard to get because of the key control issues. We took a messing rod, diameter 3.8 millimeters, cut pieces of it, soldered it together in the back, and by the technique I mentioned, we did all the dimples we wanted on it, and it works. Next slide, and here we see it, a bit unconventional, but it works. And this key, in comparison to the casted keys from Woods or Roses metal, I would, with no problem, have in my pocket. I don't think it will break, and I don't think I will poison myself with it. So far to the BKS Janus. You can later come up and watch the model, and I'm happy to explain the function in detail if anyone is interested. Next, Ray will tell you something about wrapping keys.
Yeah, okay. I don't know how many of you know the wrap, but there are a few around here. We got this machine in Munich in our Chaos Club headquarters about 2 months ago, and somewhere we thought possibly you can make keys with it. What is a wrap? Wrap looks like this. It's a square machine having an extruder moving in all 3 axes, and it's extruding a plastic. We use ABS to print 3D objects of basically any shape. There are a few restrictions. You can't print overhangs and such stuff, but you can print nice objects. You can look at the Meta Lab, for example, here on the camp to see a few one printings with a quite nice collection of objects. So the only drawback is that it uses plastic, and of course with plastic stability is an issue. So it came to us, it would be interesting if this would be possible to create keys with it. So we were thinking what kind of a key could be printed with a wrap. I don't think a BKS Janus key could be printed, but who knows, we haven't tried so far. So the larger the better basically would mean you have enough space so the tolerances aren't so tight and everything. But if it's too large, you have overhangs, for example, like in a key for a safe, you have very large overhangs. You possibly would have to print it flat, which gives other problems. So I was thinking there must be a key which is perfect for making a key with a wrap and presenting it at HAR. And people who saw my talks in New York or in Berlin might guess what I found. A key for police handcuffs. But of course, standard police handcuffs are a bit boring and they have a very small key. So I searched for a special one in my collection, and this one is used by the German police for escorts to a court and everything, and it has a quite high security lock. It's a 3-lever chap lock. For people who don't know, that's 3 discs moving up and down, or sliders moving up and down in 3 different heights, and they have to be in the correct height so the lock opens. The other interesting thing about this lock is that this key isn't so complicated. It's this key with three dents at the end, but it's only sold to the police forces of Germany because it's so a secret key. So I thought printing this key would be possibly nice if it would work. And it works. I have one here which is printed on our machine in Munich, and you can see it fits just like a normal key. You move it and it opens the lock. We had some stability issues at the head, which is why I added some plastic glue here, but we could change the model and make it a bit wider, but the rest really was quite positive experience. So why did I think this is a special nice key for Haar? The last picture shows a German Hage handcuff, and I heard Hage produces also the cuffs for the Dutch police, and they share the same lock. So we thought possibly the Dutch police should be informed about the availability of plastic keys for their handcuffs, because they're not findable by metal detectors or something. So yesterday I approached a few policemen running around here. Luckily we have a few. And I asked them if they would be interested in trying out this key in their handcuffs. They wouldn't want to. They said something like, we don't want to help you in improving your key, or we don't want you to help you checking your key. I told him, I know it works. I want to show you that it works in your handcuff. But they thought, oh, the key is secret, it's government controlled, and so then they shouldn't run around with it hanging on their belt. It was quite easy to compare it to mine, so I was sure it's the right one. I'll take this one, okay. So today, a friend of mine approached them again and told them, we verified that, we just want you to have it. So you know there's a plastic key, you can play around with it. And they let us check it. So applause for the Dutch police. They gave us a handcuff and we could verify the key works. So, go to the internet. On this page you find an STL model from which you can create code for the RepRap. It's actually not such an easy process. We tried at the Meta Lab and we failed because the settings we used in Munich are different, but it's a good basis to play with it, and I'll update it possibly when I'm back in Munich with some more models which result from the tries I can do here with other RepRaps. So the URL is key.new, key.y.new, a quite short URL. I think you can remember it. I didn't want you to forget it until you are at your PC. So now we come to decoding attacks, and I hand over to Emha for his really nice decoding attack on a brand new combination lock.
So this is now something without keys. We should see a picture. We don't. Anyway, many of you might have seen that in the lockpicking village already. We have found a new lock on the market, which allows you to lock your locker or whatever with a small padlock, which accepts a combination, but you don't need to enter any digits or dial any numbers or something, but it just reacts to up, down, left, right, movements. And it's, well, if we had a picture, it would be nicer, but anyway. This is a picture of the inside of the lock. It's really interesting to see that this lock accepts a sequence of up, down, left, right, and so on, of really any length, but there is no electronics inside. It's like a hash function, but just a mechanical implementation of that. What it actually contains is 4 wheels, and they are turned. If you move this button up, down, left, right, and whatever, you will turn these wheels. And there are gates or openings on these wheels, and if you this would be an opening here, and if they are all at the right position, then this thing can turn and it can pull on a shackle. That is for a lock collector. It's interesting in itself, but we thought it's, well, this would be a nice study of how to do a decoding attack from scratch, because nobody had that before. Let me see. Yeah. Actually, it's possible, but really difficult to decode, but it's a nice puzzle. So what you can do is you pull on the shackle of this padlock. You will see how far you can pull the shackle out, and just with any other mechanical combination lock, you will be able to get some side channel information from pulling on the shackle. You will see you can pull it out more if you have another disc set correctly, and so on. And yeah, you just need something which shows you what's inside. This can move up, down, left, right, and so on. You can turn the shackle one by one. You can turn the discs one by one, and in the end, it will open. You get some. Oh, there's actually a picture of the padlock now. Sorry for introducing this too late, but this is the lock, and this is the knob. You move up, down, left, right, and if you have some hardware also, then you can actually measure the movement of this part, and then you get all the necessary side channel information to decode that. This was an example of how to decode. Yeah, this is an example of a lock which you could decode. And what's really nice about it from a computer science perspective is that if you don't have a computer, it's a purely mechanical lock, but you really need a computer software program to decode it, to analyze it, and to work with that. Yeah. Yeah, you can get this and try it out. Yeah. Yeah, if you want, we can. If you're interested in that, come to us in the Lockpicking Village tomorrow, and we'll show you a little bit more and have a workshop on that and so on.
One step of the simulation, please.
In this PDF?
We don't have it running as software, but possibly you can tell about how it looks when you move it.
Ray hates flash players.
It needs a flash player, unfortunately, yeah. So one step of the simulation is you push the up key, and this thing will move up, and you will see that this turns, this disk turns, and this disk turns. But this computer doesn't have a flash player installed, so...
Of course it doesn't.
Yeah.
On me? For not having flash, leave the room.
Yeah, probably on me for programming this in ActionScript, but anyway. So this is a quite nice lock. It's it takes a long time to decode, to manipulate, and so on. What is even more interesting is a even more complicated lock to decode and to work with, and that's the magnetic code system. What is this? This is not a padlock, but it's a lock for your door or for high security facilities and so on. It's a locking system that needs a magnetic key. There are 4 rotors, things that turn on each side. So there's 8 magnetic rotors in that lock, and each has 8 possible positions. And if you multiply this, come up with 60 million combinations. So this is really a very interesting one. we would consider this one of the last unpicked, undecoded mechanical locks in the world, and therefore seems to be a nice challenge, right?
I think so, yes.
Yeah.
Should I continue?
Yeah.
Okay. So why is it not picked so far? I mean, it's on the market for about 20 years or something, or 15, if at least for quite a while, and nobody ever claimed he had picked it, and also nobody ever claimed he has copied keys. The opposite is the case. Even some experienced lockpickers last year published papers that this is one of the few locks where key control really works. So of course we got interested in knowing, is this true? So what's tricky about it? If you think of a magnetic lock, you possibly would think it's north-south pole magnets oriented in a key, but that's not the case. The keys, the magnets are diametral magnetized. That means they are small disks. And on one, so this is a disk, and on one side, like up, there's north, and on the other side, there's south. So you can have the disk in the key, and it has a rotational position. So it's not just north-south, but it's the orientation, how north and south are oriented in this position. So this is the 8 positions they have for each magnet. The other thing is that inside the lock, there's a thin layer of metal, it's brass or something, between the key and the disks checking the key. So there's no mechanical interaction at all possible. You can't come in with a wire or anything to feel the rotors checking the disks. Additionally, the sidebar checking the disks is loaded with a spring. So if you turn the lock, this small piece goes onto the spring and onto the sidebar. So there's no direct feedback, like in many other safe locks or combination locks, from the sidebar to you turning the lock. You can't really feel if you hit a gate or something. And as an additional layer of security, there are moving sliders in the lock which are not connected to the magnetic stuff, which check a small line on top and the bottom of the key. So you also have a mechanical component which is non-magnetic and preventing you from turning the lock.
Although it has all the stuff inside, it's still not bigger than this one, so it fits into a normal Euro cylinder. And yeah, it's a really interesting lock with lots and lots of mechanic stuff in it. Yeah.
So can it be picked anyway? People tried quite often, and we heard of several attacks. For example, like putting a diametrically magnetized magnet in it and rotating it with wires, so you rotate the rotor, but you don't get the feedback. So if you have the disk in the correct position, there would be a gate for the sidebar, but you can't really feel it. Of course, these sliders I mentioned can be picked. This actually is quite relatively easy, I would say. We managed to do it in a few seconds. Sometimes we needed a few minutes, but you can pick the sliders. And the nice thing is you can pick the sliders first. The core rotates a little bit, and then you have just the magnetic part left. So the question, of course, was, can we somehow decode this? And the question that arose while we're checking this, can we at least read it from a key? So to break key control, we would have to be able to read a key. And if you photograph it, you don't see anything, because of course there are magnets, and there's not seeable, which is a nice feature. No matter what we do, you can't photograph this key, so you can run around with it on your belt without anybody decoding it. But of course you can read them. The most simple approach is to take apart a lock, take the rotors from the lock and put them on the key. You will see the rotors align in the correct position. You have to differentiate between the 8 possible positions, which is easily doable by eye. Then you also can photograph it. So if you want a quick code reading, put in the rotors, photograph it, you have the key. The other possibility is to use a magnetic fluid card. We will see that later. So you can see at least where the division between north and south is. You don't know what north and south is, so we built another tool. The South Pole Finder, which is a magnetic North Pole on a very small key ring. You put it over the key and it moves to the position of the South Pole. And then you just have to recognize which of the 8 positions this is to read the key. But what then? As we said, it's key control, and the key is quite difficult because
what you obviously could do is you could take existing keys, right? And there is magnets in there. And if you look at the combinations which you could have there, they could be different on each side, and they could be oriented in 8 different positions. And then you need 4 of them, so you need to collect 32 pills from some keys which we didn't have. Yeah, we need to find some other way, and that was China. Yeah. You go to China, there's people who do everything for you ask them for, and it's not even very expensive. You get small, thin discs, in this case 0.9 millimeter thick, diametrically magnetized from a very rare earth metal, whatever. And then you just put them together, and that's it, right? Not really, because the magnets will not want to go together in the wrong positions. So we had to order something new. We found that, first of all, we need to put something in between so they stick together. And then we found if this is like in 8 different positions, then maybe an octagonal magnet would be better. And yeah, they do that, no problem. So we have an app, yeah, and we need a template, because you really cannot easily drill octagonal holes. We use some etching. Good enough we have in the Munich CCC workshop. There are some tools to etch stuff, of course. And I hope we can see this on the picture there. Well, what you can see there is the etched template. So this is 8 side holes, octagonal holes. You can see this magnetic fluid thing. You can see I think it's a North Pole finder, but whatever. And you can see round magnets, octagonal magnets, everything. This is a key for that system, which opens a different lock. We just did some, let's say, privilege escalation on that. So yeah, this is, as you can see, open. Yeah, that's a still different key. In this case, there were no sliders but balls, and we didn't need to pick that. So yeah, you can see here this turns very well, and essentially you can see that key control on that lock is not what you thought it would be. 20 years ago, maybe yes, because it wasn't easy to get the magnets, but these days it's really difficult to have something which cannot be copied. So,
yeah, so of course we wanted to come back to our original idea of decoding the lock. And quite a while ago we already built a magnetic coil system to manipulate the rotor. So we have something which some magnetic coils we can put into the lock, which is quite thin and everything is very, very small. And we were able to rotate the rotors electronically. And we also think we have an idea how we would find the gates. I don't want to talk about this in detail because it doesn't work yet. So possibly it will work, possibly it won't. We have problems with electronics because we need very high amps in the coil without burning it. So short pulses of the correct height to get the angles and the angles, and I think it was just like the angles and everything. But we're very optimistic that it might work someday, so watch out for new talks on this special topic. Possibly we'll also make it together or with some help from the tool guys. So if you also have ever worked on the magnetic code system and tried to do something with this, you're very welcome to join us at the Lockpicking Village and discuss in more detail what we tried and what we're going to try, or have any own ideas for this. But so far we can't really decode a lock without opening it, without seeing the key. But when we do, we know at least how to make the key. What you also can do with this key making, I think we didn't mention it, is of course you can have this privilege escalation thing. You can analyze different keys, you can see where the master keying is done and create a key with possibly the right combination for a master key. So really key control for this magnetic code system is gone.
Yeah, you don't even need to see the different keys, right? You just need to have one working key, and then you modify one position and see where the gates are and so on. So that's really a problem if you think you have something which can't be copied or modified. And yeah, now we have the conclusions, right?
I hope it's a bit slow here. What is he doing? Okay. So what is the main conclusions from our research? One, of course, is mechanical key security doesn't work. Any mechanical key in an object you have in your hands, there is some way to copy it. No matter how complicated it is, the magnetic code system was the most complicated key we have encountered so far, at least the one everybody said it isn't doable, or many people said it isn't doable, and even that got copied, and it's not even very difficult when you have the right stuff. Actually, with our kit, or with our magnets and everything, it's easier to copy this key than a normal key where you have to file and anything. So, of course, electronics might work better. Because with electronics, you can easily revoke a key, it isn't valid anymore. And so the idea is, of course, electronic would be good. But one of the problems with electronic locks is that key manufacturers just don't understand how cryptography works. Everybody in the software industry knows a cryptographic algorithm has to be published so it can be tested, and it's really just safe if you can do this without breaking its security. Nobody would do online banking with an unpublished algorithm, but everybody has it in his electronic lock door. So really this is a problem why we don't trust any electronic locks, and we would recommend nobody to do so. And the locks often have other flaws. I think in the next session by Barry, you will hear some quite interesting things about this topic. So, whoops, is there a slide missing? No, here it is. So to get to electronics lock, we, or especially MH, started a project for open source electronic locks. The idea would be to have an hardware which anybody can build, or which is possibly also independent from the software, and then electronic, where you have different possibilities to access it, to open it, like a transponder or a token or anything. And realization of this idea already is in the Munich CCC headquarters for about a year now, where we have a door which is, it has a classical lock inside because we don't trust our electronics. So if it fails, we still have a lock. But we have never used it so far. We took the best one we found, but it's, who knows? Possibly one day we can remove it. But the usual way is to log into a wireless LAN and send an authentication with your mobile device. We basically use SSH in the moment, but with keys. But you could also easily add other stuff, and then a motor is activated, which we bought. It's an Abus Homematic, from which we ripped all the wireless parts because we don't trust it. We just use a motor. It's a nice thing you can add to a lock. But of course, the idea would be to find something with an electronic, with a mechanic you possibly can build yourself, or you can easily get from other parts. So if you would be interested in participating in this, visit the open source lock. It currently goes to the Lockpicking 101 forum, I guess, where there's a special section for the open source lock. So this might be an approach to get a lock where key control really works and which you can trust besides that. So I think this would be the end of our presentation, at least if nobody has other remarks for it, and we would be open for questions.
Okay, questions. Who's got a question?
There must be one. There in the back, yeah.
Have you tried Fields metal instead of Woods metal? Fields metal isn't as toxic, I believe.
We tried Roses metal and Woods metal. Fields metal we didn't try. I'm not sure about the physical properties of it. Do you know the melting point? Is it interesting for this application?
I think it's below 100 degrees.
Oh, okay. So we'll look into this. This sounds interesting. Thank you.
Marcus?
Hey, MH. My question was about the master lock, and I think you may have told this as part of the story in the village, but I've been kind of looped. Did you acquire that as a testing sample with their permission, just by knowing someone who had a sample, or did you just get it an early model? And do you think that groups like SSDev and Tool and others, do you think getting samples before they're published should just be part of the process?
Definitely it should be. Yeah, I just got that on a trade fair, the model of this new combination padlock. I just visited a trade fair and then I got a sample, but not really for analysis or something, but just they wanted to sell it or they wanted to create a market for it. Yeah, obviously it would be a really good idea for lock manufacturers to have independent experts test their lock. And to some extent it's done, and to some extent there are security holes not found. In this particular lock, I would say, well, it's a 20, 25 euro, whatever padlock, and if it takes half an hour to decode it, then that's not a security hole, then that's a game for lock pickers. Yeah, in general, it's obviously a very good idea. And in some cases, there are collaborations between lock manufacturers and Locksport, but that's really very few cases and should be expanded, definitely.
Okay, one thing I forgot, I wanted to mention it because otherwise I'm told, why didn't you tell us so? We have printed in Munich about 10 of these keys before we left. So tomorrow at the Lockpicking Village, I'm giving a talk on handcuff picking and everything, and I will sell these 10 keys for a good cause, and that is for buying new stuff for our RepRap in Munich. So if you want to have one of the 10 first plastic handcuff keys for the Dutch and German police handcuffs, or Dutch and German, then come to the talk and buy one of our 10 keys to support our RepRap project. I think it's at 12 or something tomorrow in the Lockpicking Village. Check with the Lockpicking tent. So one more question possibly?
12:30. It's at 12:30, the talk.
Okay, thanks for telling me when my talk is.
Just out of interest, the EVA MCS system, how much did it cost to get the magnets made and defeat the system?
That's actually not that expensive. The most expensive part is sending them the specification and getting a tool made for the magnet. So that's about, I think, 100 euros or something. And the number of magnets you make adds a little bit to it. So we made about 3,000, I think, because it wasn't much more expensive than 1,000. So the lower three-digit area of euros is what you need to get these magnets. And then you can make 1,000 keys.
So how much is the kit?
We don't have a real kit, I think, do we? Not yet. Possibly on one of the next lockpicking events we would have, because you need a key blank to cut apart, and so we don't have this. We didn't etch so much metal, but basically you should know what to get, and if you want a few magnets, approach us and we'll sell you a few.
So basically it costs less to break the system than one lock costs.
Yeah, making your own key is cheaper than ordering one from the factory.
Okay, thank you for your time. If you're interested in this topic, you may want to stay here because there's another lockpicking talk coming up.
Yeah, more lockpicking.
So.